Welcome, maths fans. That was Bob the Piper with Top of the World, and that was written by the Carpenters. So if you're wondering where that's from, and any parents out there listening, the Carpenters on Top of the World. And that's how you should feel this morning, having cracked fractions this week. You should be on top of the world, having cracked them. Just one last thing, one last piece of the puzzle to go, and then we're done it. Okay, so a big welcome to everybody. Usual crowd here this morning, ready to watch some action-packed maths live. Maths live on the video. Okay, so without further ado, we'll get cracking. So the function of today is cracking, or the learning objectives are cracking this, adding and subtracting fractions. Now, yesterday we looked at multiplying and dividing fractions, and there was a little bit of theory there and quite a bit of explanations, but overall, if we get a bit of the theory locked in to our brains and we know how to use those skills that I showed you about going across the top of the line, going across the bottom of the line, top of the numerators together, the denominators together, and so on, and then on division, flipping the second fraction, multiplying. Okay, but if you want to see some of the theory behind why those skills happen, please watch the video in more detail. So let's move on to adding and subtracting fractions. Now, I'm going to do this in a bit of a strange way, okay? So what we're going to look at is misconception, because this is the biggest misconception of maths that there actually is. Okay, I think anyway. So this is a really big misconception, and we are going to do that misconception now. So this is the wrong way, folks. I don't very rarely do this, show you the wrong way first, but it's important because we don't want to be making this mistake. Okay, so let's have a little look at this question. A third plus a half. Now, every single year I teach fractions, I would say at least half the class do this question this way. So this is wrong. I'm going to put a cross there, a few crosses to show you this is the wrong way. Okay, but we need to know how to do the wrong way so we don't make that mistake in the real thing. Okay, so watch what I do. So a third add a half. So it's going to be 1 add 1 is 2. 3 add 2 is 5. So that makes 2/5. Right, so let's have a little kind of look at what's going on then here. So we've got 2/5. So if I draw a third, and if I draw a half, okay, and we show you the bit that we need there. We need that bit and that bit. Oh, I've got my highlighter. Gonna need a highlighter. And these highlighters. You can overdo it on highlighting though, I reckon. So look at that. So we're adding these up. So we're having that green one. We're eating that green bit of pizza. We're eating that half a pizza, and this is the amount of pizza we're gonna end up with. 2 out of 5. So there's my pizza. This time, I'm going to split it up into 5. They're supposed to be equal parts, but I'm drawing this by hand, so you'll have to bear with me. That's not bad. It's pretty close. So I'm eating that much, and this is what I've got left. I've got 2. Well, this is what I've eaten. This is what it makes. Sorry, not what I've got left. This is what I've eaten. That's what I've got eaten. 2 out of 5. So the question here is, look, I've eaten more than half. Oh, I won't say eaten. I've taken more than half. I've taken a third, which is well over a quarter. So half and a third. So we should have eaten a half and a third. Joining them together, by the way, this is what we should have kind of taken. I won't say eaten. That's what we should have taken, eaten, whatever. Okay, so it's sort of this amount of stuff, this amount of pizza, that's what the answer should be. And yet, we've got less than half. So you can see that something's wrong. Okay, so that's wrong. This method of adding the numerators and adding the denominators is not what we need to do. So what is going on then? Why doesn't that work? Okay, bear with me for some paper. I'll have to get some more. Hold on a second. All right, so that's not going to work. So what we need to do is we need to think about what's going on. Now, if we add these two fractions, okay, we split them up into basically different amounts. So this one's got thirds and this one's got halves. So we're adding thirds with the halves, and that's okay, but we can't add them in that format because we've got to have the same amount. It's like saying a quarter add a quarter makes 2 quarters. Okay, in fact, let's do that, quarter add a quarter. Okay, this is another good example to show you, because this is the correct way now. A quarter add a quarter equals 2 quarters, which is actually effectively a half. So let's have a look at the numbers part on this. So the numbers part shows that we are adding the top values. So that bit was kind of correct. 1 add 1 is 2. But look at the denominators. They're all 4 all along. So that rule is that we can only actually add fractions if they have the same denominators. Okay? If we don't have the same denominators, it's like adding 2 different kinds of amounts, and it just doesn't work. Okay, so we need the same denominators. So that is the first thing we need to learn. Same denominators are needed. Okay, so that's the first thing to check. The denominators are the same, we can add them. So let's just do a really easy sum calculation. Okay, so type your answers in there, folks. Remember the division sign for typing quickly is use that one for speed. Okay, 3/7 add 1/7. Let's see some answers. Okay, so we've got 4 people joining us this morning. Not as many as normal. People haven't got up probably because it's Friday. Well, a big welcome to you guys if you're coming later. But I'd like to welcome and say good morning to the following people. So we've got Lydia Monks this morning. Okay, Dylan Fullard's come in. Lydia Rumsey, well done. 1, 2, 3. Yeah. So is Alfie with us this morning? Oh, we've got 5. Well done. Okay, and the answer's coming in now. 4/7. That's right. Great. What it is not is 4 out of 14. It is not that. Okay. And that's what a lot of people do. Right. So that begs the question then. If the denominators are not the same, what do we do? The classic half add a quarter question. I'm just sort of drawing them out quickly. Sorry, this diagram's not very good. It's like a little bit of a mouse, actually, that does. Okay, computer mouse, that is, not one that squeaks. So we can clearly see from the diagrams that this and this are going to make 3 quarters, like that. So again, if we added the numerators as they are and the denominators, you get 2 out of 6. So we've got to move on from that. We don't add denominators, we only add numerators. Okay, so the answer's 3 quarters. So how do I get there? Well, it all lies with getting the same denominators. If we went back to this question, the denominators are the same. So how do we make the denominators the same? Well, the half is the same as 2/4. So 2/4 plus 1/4, that can stay, is 3. Add the numerators, keep the denominators the same, and that's how we do it. Okay, because this half is 2/4. And if we write the half as 2/4, and remember that's an equivalent fraction, we're allowed to do it, that gets the denominators the same. Now there is a fancy trick, but I'm reluctant to show you that until right at the end, because we've got to concentrate on understanding the theory first, and then we can apply that trick later on. Okay, so let's have a look at some questions then. There, I did print some off. I'm not going mad. There we go. All right, so let's zoom in on the first lot. All right, I better write the first few out. All right, 1/8 plus 5/8. All right, so first thing to check, have we got the same denominators? Yes, we have. So if we've got the same denominators, we keep the denominator the same in the answer, and then we can simply add the numerators. Okay, so that's quite an easy one because the denominators are the same. Here, more tricky. So 2/3 add 1/4. So in this one, we've got to get the denominators the same. So the first thing to check is which number will give us a denominator that's the same. That's called a common denominator. Okay, so can anyone tell me which number I'm going to use to get the denominators the same? One denominator is 3, one denominator is 4. Remember that we can multiply both fractions by numbers to change them, but we've got to do the same to the numerator and the denominator. Does anybody know what the denominator is going to be? So pass that into math cyberspace. Yep, we've got a few answers coming in now. Well done, Lydia. 12. Okay, brilliant. So how did we know it's 12? Well, it's the lowest common multiple. That's what we need to find. And multiples are just times tables. 1 3 is 3, 2 3 is 6, 3 3 is 9, 4 3 is 12, 1 4 is 4, 2 4 is 8. Stop when you know the numbers in that number. 1 4 is 4, 2 4 is 8, 3 4 is 12. So the lowest common multiple is 12. Now, folks, if ever you're stuck, there is a little trick. Multiply them, and that's going to give you a common denominator. Right. Okay. So we need to change 2/3 into something out of 12. What number? So that I'm going to put this 2/3 here. So I'm going to multiply both of these by a number to get something out of 12. So I start here on the denominator, and it's a 4 because 3 4s are 12. So this is how we get the numerator part. We've got to remember to do the same thing. 2 4s are 8. So that's the 2/3 is 8 out of 12. The quarter, so again, it's 4 3s are 12. It's got to be on the top. So it's got to be the same number. So that's times 3. So what do I times the top number by? Okay, so we're going to times it by the same number. Once 3 is 3. So that's 3 out of 12. And then the last bit is normally the easy bit. 8 add 3, 11 out of 12. If you're asked to simplify the fraction, do so if you're not asked to simplify it, you don't need to. All right, let's have a look at part 2 here. So first one, 8/9 minus 4/9, exactly the same process. We've got a common denominator there, so that's okay. Okay, because addition and subtraction, the reverse functions, the method here is exactly the same. I've got 8/9, I take 4/9, that means I've got 4/9 left. Denominator stays the same. Okay, on B, right, let's do B in a bit more detail. 9/11 minus 3/5. Right, multiples. Multiples 11, multiples of 5. Right, I'm guessing it's going to be 55. One way of doing it is take the biggest number first, biggest denominator first, and just do multiples and see if 5 will go into it. Once 11 is 11, 5 won't go into it. 2 11s are 22, 5 won't go into it. 3 11s are 33, 5 won't go into it. 4 11s are 44, 5 won't go into it. 5 11s are 55. If you times them, you're not always guaranteed to get the lowest number that goes into both. Now, that's not an issue. This will still work, but you might make it more complicated later on. It swings and roundabouts. Or you might get to the end and need to simplify a little bit more than you would if you got the lowest common multiple in the first place. But like when I talked about, doing a number of steps to simplify, this is a similar idea. Okay, it doesn't matter if you do the highest common factor, lowest common, no, I'm getting these mixed up now. It doesn't matter if you go for a higher common factor as long as you get the answer in the end. Okay, right. So this makes it a little bit easier because 9/11 are times by 5, 9 5s are 45. 5 to make 55, 5 11s, so that's going to be 33. So 45 minus 33, so that's going to be 12 on the numerator out of 55, and there we go. Brilliant. Okay, right, so that's fantastic. Well done for listening. Now I'm going to show you a little bit of a trick. I'm going to use that. I call this the Union Jack method. It does work, but I think the most important thing about this process is to understand why we're doing what we're doing. If you've got that, then you can use the trick. If you don't get what's the understanding of what's going on, the idea of this common multiple, lowest common multiple, which gives you that common denominator, common meaning the same, then you shouldn't use this trick until you've understood what's going on here. Right, so going on to this again, I'm doing the exact same thing, but it's kind of a little trick that'll get you through and get you through quickly. Right, you got to learn it. Now, although it's add or times or add or take away, subtract, we're multiplying to get the sum set up. 5 11s are 55. So we go there. That's the first bit. Then we go there. That's the second bit. 5 9s are 45. Effectively, what we're doing is timesing both of them by 5 to make your first number. 5 9s are 45. And then we go there. 11 3s are 33. I sometimes call this a Union Jack trick because you can make a little bit of a Union Jack afterwards. There we go. Although we've got St. George's flag as well fitted in. But anyway, let's move on. So that sets my sum up very quickly, and they're all out of 55. So therefore, we end up with 12 out of 55. So that's a nice little trick. Let's do another one using that trick. Okay, just looking at my Questions. Try this. 7 out of 10 minus 5 out of 9. Okay, so using the trick, 10 nines are 90, 7 nines are 63, 10 fives are 50. So it's quite quick and easy to do, but you've just got to remember that you've got to get the understanding of this. Where does this number come from? That number is the common denominator. Okay, that is one fraction, 63 out of 90. That is the other fraction, 50 out of 90. To get the 90, we're timesing by 9, so we need to times the 7 by 9. To get the 9 by 90, we're timesing by 10, so we need to multiply that by. Okay, I think you get my drift. Understanding is key. There we go. That's my answer. But it is quite easy to do once you've cracked it. And again, the important bit here is that when you see these, another confusing bit is when you see this, to set the sum up so that we've got a common denominator, we need to do adjustments with multiplying both fractions. And that's the confusing bit. But in recap, 1, don't make the mistake of adding numerators and adding denominators. We need to set the sum up so they've both got the same denominator. Once they have got the same denominator, we simply do the sum for the numerators only and keep the denominator the same. The process is exactly the same for addition and subtraction. And one thing I would say is that try and if you're using this kind of little trick method, try and stick to the same order. Do those first, do those second, and those third. Because if you don't, when you're taking away, you end up with the first number smaller than the second number. So you go there, there, and there. Just get used to that. Okay, even makes a little time sign at the end to remind you should be timesing to set the sum up only, then add or take away. Boom-tastic. Boom-tastic. Right, okay, some information for you Maths Live fans out there. Next week is half-term week. Now, I know that the maths teachers are saying get everything up to date on all your maths up till now. Chances are we won't be going back to school next term, so we need to start afresh on the Monday, unofficially, well, officially back, but we won't be back. So you'll find that most maths teachers are not setting new stuff, but it's important that you get up to date with any outstanding work. Okay, and I know the maths teachers will be getting their marking completed ready for a fresh start a week on Monday. So because it's half term, because it's bank holiday, we're going to have a week, a free week from Maths Live. Okay, but what I want you to do is, in the meantime, you can always message me and message me with some ideas of where we're going to go with Maths Live further on. I'm open to suggestions. Okay, and musical requests, fine, absolutely fine, from Bob the Piper, 20 quid an hour. So we have to use him carefully. Maths Live will take place a week on a Monday. Okay. Requests can be made in the meantime. Keep your eyes open for any messages. I might post a few quick videos, quick tricks or whatever next week if I get the opportunity, but get yourselves up to date with all your work ready for a week on Monday when we start the Google Classrooms up and running again. And the maths teachers all know what they're doing, including me now. So there'll be work coming at you after the half term. Have a lovely break, folks, and it's been a pleasure, and I'll see you soon. So we'll just finish off with a bit of Carpenters and then we're done. Die down. Right, he's not having his money. He's made a few mistakes. Okay, I'm giving him tenner. All right, see you a week on Monday, folks. Been a pleasure. Make sure you're there. See you over and out. Take care.